All right, next in the inequalities is dealing with compound inequalities. And one of the first things we have to do is be able to understand what a compound inequality means. Essentially, what I can do with a compound inequality is I can take and say, well, in this first one, if I just completely ignore this right-hand side, I have an inequality. It says 2 is less than or equal to x. Well, I can also ignore this part and say x is less than or equal to 5. Put them together, and I have one big inequality. So what I'm going to do is I'm going to first say, well, I can rewrite this as two inequalities. 2 is less than or equal to x, and x is less than or equal to 5. Just by first ignoring this part, and then ignoring the part on the left. So I get two inequalities there. I can do the same here. -1 is less than x, and x is less than or equal to 4. Now, normally we don't like having the x on the right, so I can go and kind of switch that first one around in both cases. X is bigger than -1, and x is bigger than or equal to 2, if that makes it easier for you to understand what's going on. Similarly, we can work backwards, and we can make two statements into one big one. The way I do that, with x is bigger than 2 and x is less than 0. So what I'm going to do is say, well, what's the first number on here? Actually, I meant to make this a -2, not a +2. So x is bigger than -2 and x is less than 0. The question you ask first, what's the smaller number, -2 or 0? -2 is a smaller number. So to make an inequality here, starting with -2, I need to flip this guy around. -2 is less than x. That's what I'm going to first begin with. And now I'm going to continue, if I ignore this first part, with the second part of the inequality, which is already in order then. X is less than 0, just like that. Same here. Which number is smaller between the 5 and the 12? It is the 5. So I'm going to flip that first equation around, and then I can continue with the second equation. And it should make sense that I'm going from a smaller number to a bigger number in both cases. Okay? Now, let's try to graph all these. As a reminder, just regular graphing here. If I started with x is less than or equal to 4, it's a filled-in circle. And going to the left, the arrow's kind of helping you out on where to go. Numbers less than 4, there's like a 0 here, those are numbers less than 4. In ones like this, where I have the x in between two numbers, literally it means I'm in between them. So what I'm going to do here is I'm going to shade, well, first, this 2 is a filled-in circle because it's less than or equal to. And this one's going to be an open circle because it's just less than. And x is in between those two numbers. I literally just shade in between the two numbers. Those ones that are compound should be very easy to do. I just shade in between them and follow the signs. Now, these ones that are separate statements are going to be a little bit more complicated or cumbersome. Here's what we're going to do. So first, I'm going to plot the two numbers that I have, 2 and -2. I have that actually for both of these cases. Okay? But what I'm going to look at here, for this one, I want x is bigger than -2, bigger than or equal to. So that means I'd be shading kind of like this. I also want x is bigger than +2. So I'd be shading like this. When I see the word and, change that, make this green. When I see the word and, that means I'm looking for where they overlap, where my shading overlaps. And that means that my answer will be just this part right here. So I'm going to start at 2 and go everything bigger, because that's where I had my shading overlapping. In this case, it was the exact same, except the word was or. So we had this to begin with, plus the bigger than 2 going in that direction. When I see the word or, that means, if I change my color again, or means anywhere. So anywhere I have shading, that's where my answer is. So I have shading going all the way back this here, so I can start right there and shade everything going to the left, just like so. Okay? Now, there are a couple special cases here. Let's see what happens when I graph these guys. So I have x is bigger than 5 and x is less than 1. So if I graph these, x is bigger than 5, so that's going in this direction. X is less than 1, that means I'm going in this direction. Remember, and means overlap. Is there any overlap there? No, no overlap exists. Therefore, this is one of those no solution problems. There's no solution. Sometimes we put the 0 with the line through it. Does not work, will not work. Okay, this one here though, I'm just kind of switching it around. Instead of saying and, I'm going to say or. So the picture is still the exact same. But all we care now about is or. Actually, it would help if I actually read the problem. So let's first say, okay, let's make this here. Let's change these signs around. Let's say it was x was bigger than 5 or x is less than 1, like we did before. Okay? We would leave our answer just like this. I want any number that is less than 1, so 0 would work, or it could be bigger than 5, so like 6 would work. But there's no number like in this one that is both bigger than 5 and less than 1. That's why there's no solution. Now, let's say I have, like I had originally, where I flip these signs around. And I say or. So let's see how this one looks when I graph it. I want all numbers that are less than 5 or that are bigger than 1. So if I graph this, the less than 5 part will look like this. The bigger than 1 part will look like this. Or, so I don't care where it is, I just want anywhere there's shading. I don't need overlap. Well, when I do that, well, I'm literally shading the entire number line. So again, this is one of those where I have the all real numbers, or I say all reals, or I say infinite solutions. I have many ways to write this, but no matter what number I pick, it will work for this problem. Okay? Now, here's just 2 more sets that I want you to try to do. We need to try to solve these equations. Okay? Now, when we solve compound inequalities, when we solve a regular inequality, like if I ignored this part real quick, I would just solve by adding 7 to both sides, and then I would have to divide by 3. Guess what? It doesn't matter if I have this other part here as well, because if I add 7 to these 2 parts, I'm just going to add it to this third side of the inequality as well. You need to add it to every piece of the puzzle, 1, 2, 3 in this case. So I'm going to get 9 is bigger than or equal to 3x, which is less than, or those are less than signs, less than or equal to 18. I'll then divide by 3 and get 3 is less than or equal to x, which is less than or equal to 6, and that's how I would solve my inequality. Okay, same here. If I'm going to go with this, I'm going to first subtract 2 from both sides, leaving me negative 5 less than negative 5x, which is less than 15. I'll then divide all sides by this negative 5. So I'll get 1 here, I'll get x here, and I'll get negative 3 here. I divided by a negative though, so I need to switch all signs. 1 is bigger than x, which is bigger than negative 3. The proper way would probably be to put it in least to greatest order, like so. But either way, you know x is between those 2 numbers. So if I did need to graph these, I would have negative 3 and 1, I'd be shading in between. And with this one, I would have 3 and 6. Those are filled in, and I'm shading x in between. Okay? Here's 2 problems. I'd like you to give them a try. Actually, no, I would not like you to give them a try. I'll do the first one with you, and then I'll have you try the second one. Okay? Let's first simplify by distributing. So I get 2x plus 6 is less than 6. So I'm going to have 2x is less than 0, divide both sides by 2, and I get x is less than 0. That's a regular inequality. Guess what? I'm now breaking it up and doing 2 inequalities at once. Add 2 to both sides, x is bigger than or equal to 10 is my other inequality. So, again, if I look at a number line, I want where x is less than 0 and where x is bigger than or equal to 10. So I'm shading like so and like so. My word was or, so I want just either case, so I'm done just as it is. If this was and, then it would be a no solution because there is no overlap. Okay? Now, in the second one, it is and, so I am looking for overlap. So why don't you go ahead, pause the video, and see if you can solve this compound inequality and graph it as well. Alright, if you remember from a previous video, we were supposed to multiply both sides by that denominator 6. That gives you that x is less than 12. And then we have over here, if I divide both sides by 5, I get x is bigger than 3. So I need to look and see where I have 12 and 3. I want numbers less than 12. And I want numbers bigger than 3. The word was and, so I want the overlap. So my official answer is this part I'm going to put here in yellow. The part in between 3 and 12, because that's where I have this overlap of my shape. There you have it. Best of luck. Yay, compound inequality.